Welcome. Today we're going to talk about the power rule for exponents, basically answering the question, what is the power rule? Let's get started. Recap. Exponents, what do? They give us repeated multiplication of some base. We'll say base number. Okay. So if we remember the product rule, if I have some number b raised to the n power times that same number b raised to the m power, so the bases are the same, I get b raised to the n plus m. Example would be 2 squared times 2 cubed equals 2 to the raised to the second power plus the third power is 2 to the fifth. Okay. Quotient rule. If I have b to the n over b to the m, so over means divided by, it's going to give me b to the n minus m. Example would be 3 cubed divided by 3 squared equals 3 to the third minus 2 equals 3 to the 1, which is just 3. So here we have the product rule we just talked about. Okay, don't need to go into it in too more detail. This is going to be our power to the power. I have a base a raised to the m power, and then I raise this entire exponential expression to the m power. So a to the m becomes our new base. And so what I do is I just multiply those exponents together. What's with all the letters? We use letters to represent any general number. Okay, in this case, a does not equal 0. Let's move on. So first, let's see what this looks like in practice. So I have 2 times n to the fourth, and then I raise this entire thing to the fourth power. So when in doubt, write it out. We're going to do expanded form to show you what's happening. So I have 2 to the n to the fourth power, and so here's my base. This whole thing is my base here. And I'm going to be doing repeated multiplication of that base 4 times. And we remember from the product rule, I'm going to multiply my coefficients. So I have 2 times 2 times 2 times 2. Check. Took care of the 2's. Then I have n times n to the fourth times n to the fourth times n to the fourth times n to the fourth. So I took care of those. Check. Just staying organized. 2 times 2 times 2 times 2, that is 4, 8, 16. N to the fourth, this just becomes n to the 4 plus 4 plus 4 plus 4. Well, what is 4 plus 4 plus 4 plus 4? That's the same as 4 times 4. So I have 16n to the 16. Okay? So I kind of skipped ahead here. How do I use 4 and 4 to get 16? These are my exponents, right? This is the exponent of the base, and this is the other exponent. What math operation goes here between the 4's to give me 16? Well, it's multiplication. I'm going to use the dots, okay, so we don't confuse it with the letter x. Let's see another example. Here's our base, 3 times a times b to the fourth, and then I raise this entire thing to the fourth power. Let's write it out. 3ab to the fourth times 3ab to the fourth times 3ab to the fourth times, you guessed it, 3ab to the fourth. Well, 3 times 3 times 3 times 3, check, takes care of my coefficients, times a times a times a times a, check, took care of the a's, and again we have something to the fourth power, b times 4 times b times 4 times b times, b to the fourth. Guess you cannot say it 10 times fast. So 3 times 3 times 3 times 3, that's going to be 81, right? This is 9, this is 9. 9 times 9 is 81. Then I have a times itself 4 times, it's a to the fourth. B to the fourth times itself 4 times, which is b to the 16th. Again, so if you notice, I have a to the 1. So what's happening is I'm really just doing 3 raised to the 1 times 4 times a raised to the 1 times 4 times b raised to the 4 times 4. And that is how I am ending up with 81 times a to the fourth times b to the 16th. So let's do it this time. We have our base here, 2 times x squared, and then we raise that whole thing to the negative fourth power. Not a big deal. I'm going to write this in red. Let's write it, but without using our expanded form. So I'm going to have 2 to the negative 4 times x raised to the 2 times the negative 4. So 2 to the negative 4 is going to be 1 over 2 to the 4th. Remember, if we have a negative exponent, we have to flip our base, so it becomes, instead of 2 over 1, now it's 1 over 2, and I raise the 2 to the 4th. Now I have x2 times negative 4 in my exponent gives me x to the negative 8. So I have 1 over x to the 8th now, took care of my negative, see? This gives me 1 over 2 to the 4th is, what is that? 2, 4, 8, 16, x to the 8th, okay? A little complicated, but if we make sure we remember what happens with multiplying positive times a negative, and then when we have a negative exponent, what we do, we'll be fine. Okay, a new one. 2 times x to the 4th times y to the negative 3, and then I raise this entire thing to negative 1. So this is my base, right? Even though it has lots of variables in there. We're going to stick to the plan. We'll switch to blue. So I have 2. Now it's raised to the negative 1 times x to the 4th times negative 1 in my exponent times y raised to the negative 3 times negative 1 in the exponent, right? So we're going to deal with these exponents first. 1 over 2 to the 1 times, now I have x to the negative 4. I'm going to be flipping that. Y. Negative 3 times negative 1 is positive 3. Okay. So I'm going to write down underneath 1 over 2 x to the 4th. So I took care of that. Here's my negative exponent for my variable x. So that's taken care of. Y to the 3rd. This is a positive exponent. So this is times y to the 3rd. And I'm going to simplify it again. We don't need to write 1 times y to the 3rd. We can just write y to the 3rd. Final answer for this sample problem. Last sample problem. There's a lot going on. This one's complicated. So we're just going to be organized and write out the process. So here we have a base raised to the negative 3rd. So it's 2 times y, which is to the first power. We just don't write it. Times x to the negative 4th. And then this entire thing to the negative 3rd. Divided by y times x to the negative 1. So we have some quotient rule stuff going on. First thing I'm going to do is simplify the numerator. So that's 2 to the negative 3 times y to the negative 3, right? So it's almost like distribution. Times x to the negative 4 times negative 3 all over y to the x negative 1. Well, I have a lot of negative exponents, so things are going to be moving here. And then real quick, before I do that, this is 12. Negative 4 times negative 3 is positive 12. So I have x to the 12th stays in the numerator. This guy is going to go up, so that's times x to the 1. Then I have 2 cubed, right, because I have a negative exponent here. So this entire thing is going to drop down into the denominator. And then let me change colors here, or use my pointer. And then I have y to the negative 3, so that's going to drop down here. Times y cubed, and then I have y to the first power in the denominator already, times y. Let's simplify. So we have the product rule here with x to the 12th times x to the 1. We also have the product rule here, y cubed times y. So I'm going to have x to the 13th power over, so 2 cubed is 2 times 2 times 2, which is 8. 8, and then y cubed times y is y to the 4th. This is our final answer. There's a lot going on, so if we just keep track of one thing at a time, we should be fine. Recap. So we have the product rule, which we discussed before, where we multiply two bases together, and if, two exponential expressions together, and if the bases are the same, which they are here, we add the exponents, right? So when we raise an exponential expression to a power, we multiply those exponents together. Those of you who are in my class, your assignment is going to be the power rule worksheet, which you can find in our filing box. It's also located in the Google Classroom. If you have any questions, you know how to get a hold of me. Good luck.